By now, you should be familiar with running the functions of the IGC CSN model. However, this is just an intermediate step and further analysis is needed. Currently, your results are stored as a list. In R, a list is a flexible data structure that holds various types of elements, such as numbers or strings. The list that you will have obtained in the version of the model holds 13 elements, like the number of workers and residents, which match the data in the initial file of characteristics. You will have the productivity and amenities variables, and these will be adjusted for the agglomeration externalities, and a variable indicating land development density or floor space prices. There will also be a matrix showing the percentage of residents from each location who commute to work in other locations. And most importantly, you will have a measure of the city's aggregate welfare. You will have two lists containing these variables, one for the baseline and one for the counterfactual scenarios. To analyze the counterfactual scenario, you can compare the values from both lists. You can choose to analyze the results in absolute terms to see how different variables change across the counterfactual scenarios. Or, alternatively, you can examine the changes in terms of percentage changes, which will analyze the difference in the variables in relative terms. Absolute analysis provides precise numerical values offering clarity and specificity, which is useful for detailed reporting and exact quantification. However, this analysis lacks contextual insight and can be limited in understanding trends or comparing data across different scales. On the other hand, relative analysis compares values to one another, revealing patterns and trends through percentages or ratios, which helps in benchmarking and understanding data in context. While it offers valuable comparative insights, it can be more complex and potentially misleading if it is not properly interpreted, especially if the baseline or reference point is not well explained. One of the most valuable variables created by the model is the measure of aggregate welfare. This measure encompasses various factors, including amenities, housing prices, salaries, and travel times. Unlike the other outcome variables that had a measure for each spatial unit inside of the city, the aggregate welfare is a single number that captures the overall changes in quality of life or satisfaction for all the residents in the city. The aggregate welfare is positively correlated with the level of amenities and wages, as these make people happier, and is negatively correlated with the floor space prices and the travel times. The welfare can be transformed into compensated variation, which converts the welfare estimates into monetary terms. Compensated variation quantifies the amount of money required to maintain the same level of utility or well-being after a change in certain economic variables. Here's how the compensated variation works. First, you need to have some welfare estimates that indicate the percentage change in the overall well-being or utility within the model. Then, you will convert these estimates into monetary terms by multiplying the welfare estimates by the average annual income of the city. You can obtain the average income in the city by utilizing data from national statistic agencies that conduct comprehensive surveys and censuses, which include income metrics. Reports and data from international organizations such as the World Bank and the International Monetary Fund also provide valuable insights into income levels at the national level. This data allows to calculate the amount of money that would be needed to offset the effect of price changes or other economic shifts, ensuring that consumers' utility levels remain consistent. Let's show you how to calculate the welfare percentage changes using R. First, you need to access your directory where you will be storing all the results from the counterfactuals that you have previously run. Then, all you need to do is to have mainly two lists of results. One, the results from the baseline model, and two, the results from the counterfactual model. Each of these lists will hold a variable with the aggregate welfare that will be called upper U. Then, to calculate the percentage change of welfare, you can use this line of code. As you can see, the percentage change in this example is 2.45%. If you wanted to convert this number into compensated variation terms, you would need to multiply it by the average income in the city.